So now we can come back and talk about how do we actually find the final interval of convergence, including our endpoints. So the way we do this, we use we use the ratio test to find the preliminary interval of absolute convergence. So because we're using the ratio test and using the absolute value signs, our preliminary interval is always for absolute convergence. But we haven't talked about what about checking the endpoints. So what we'll then do is take each endpoint, plug it in for x in the series, and treat the resulting series like a brand new series, checking first for absolute, then conditional convergence. If it converges for that, regardless of the type of convergence, then you can go ahead and say it's part of the interval. I'm including the whole check absolute, then conditional first, if we were asked if it's absolute or conditional. If it doesn't ask absolute or conditional, you're just checking the endpoints for do they converge in any way. Again, I know this is confusing. Examples are a big, big help. So we're going to find the interval of convergence for the series where n goes from 1 to infinity of -1 to the n plus 1 times x to the 2n over 2n. So we always start with the ratio test to find our preliminary interval. So we're doing the limit as n goes to infinity of the absolute value of -1 to the n plus 2 times x to the 2 quantity n plus 1 over 2 quantity n plus 1. And then I'm just going to do my multiplying by reciprocal here right off the bat. 2n over -1 to the n plus 1 times x to the 2n. Well, x to the 2 times n plus 1 is x to the 2n plus 2, which is x to the 2n times x squared. This will be 2n plus 2. So I end up with the limit as n goes to infinity of the absolute value of 2n plus over 2n plus 2 times -1 times x squared. Well, the -1 is going to get taken out by the absolute values, so there's not going to be a -1. The absolute value of x squared, well, x squared is already going to always be positive, so it's just x squared. If you have x squared inside of parentheses still, that is perfectly correct as well. There's nothing wrong with it. And this is what I'm left with. Remember, whoops, sorry about that. I can take the x squared out, or the absolute value of x squared out, because according to the limit, only n is changing. So I can do L'Hopital's rule because my limit has infinity on top and infinity on the bottom. We're going towards those. I'm going to do n behavior models because n is going to infinity. And I get that this is x squared, which needs to be less than 1. So that means x has to be between -1 and +1. This is my preliminary interval of convergence. A lot of times on the AP exam, students stop there and say they're done. But that's just preliminary. If I were asked, that's also absolute. But I'm not asked, so I'm not even going to worry about if it's absolute or conditional. So next, I need to check my endpoints. So one of my endpoints is -1. So I'm going to plug -1 in for x in my series. So I have the series where n goes from 1 to infinity of -1 to the n plus 1 times -1 to the 2n over 2n. Well, do some algebraic simplifying on my series. -1 to the 2n means it's -1 to an even power, because no matter what I plug in for n, 2n will be an even number. -1 to an even power is always 1. And I'm not asked for absolute or conditional, so I'm just going to go straight to just does this converge? I notice this is alternating. I notice that 1 over 2n is always positive. As n gets bigger, 1 over 2n is decreasing. And the limit as n goes to infinity of 1 over 2n is 0. So that does converge by our alternating series test. So that means -1 is part of my interval of convergence. So then I need to check, what about when x is the other endpoint, +1? So I have n is going from 1 to infinity for the series of -1 to the n plus 1 of 1 to the 2n over 2n, which is the series as n is going from 1 to infinity of -1 to the n plus 1. 1 to any power is just 1. And I end up with the same series. So I already know that it is alternating. The non-alternating part is positive. The non-alternating part is decreasing. And the limit as n goes to infinity of the non-alternating part is 0. And therefore the series converges. So that means +1 is also in my interval of convergence. So my final interval of convergence is from -1 to 1, including the endpoints. Some other examples of this, just so you can see some other examples. This is a pretty typical one in terms of what the AP would ask. They typically, if they wanted you to check absolute and conditional, they're going to be more like example 1 here. Whereas if they're finding the interval of convergence, they're not really caring is it absolute or conditional. For another example of this, I'm given this series where n goes from 1 to infinity of the quantity 10x being raised to the n over n factorial. To find the preliminary, I always start with the ratio test. So I'm doing the limit as n goes to infinity. All my terms are positive anyways, but I'm going to use my absolute value to guarantee it because I don't know if x is a negative number or not. Of 10x to the n plus 1 over n plus 1 factorial, and then n factorial over quantity 10x to the n. When I simplify this, I have the limit as n goes to infinity of the absolute value of 1 over n plus 1 times 10x. Well, as n is getting bigger and bigger and bigger, this is approaching 0. And 0 is always less than 1. So what this means is that this converges, this series will converge for any real value of x. So my interval of convergence is that x could be all reals. If I go to my last example here, and I want to find the interval of convergence for the series where n goes from 1 to infinity of n factorial times x plus 1 to the n. Again, I always start with the ratio test. So I'm doing the limit as n goes to infinity of the absolute value of n plus 1 factorial times x plus 1 to the n plus 1 compared to n factorial times x plus 1 to the n, which is the limit as n goes to infinity of the absolute value of n plus 1 times x plus 1. Well, as n is going towards infinity, this goes to infinity, which is bigger than 1. So this diverges for all values of x except the center. And this is because the center, the way we build our series, the center is always on the function itself. So the center is always convergent. It's not a very helpful one because since we already know the function value at the center, we wouldn't want to use a series to estimate the function there. So identifying the center. What I notice is that for the x plus 1, that looks like x minus negative 1. So I'm really just seeing x minus what? Well, it's always x minus the center if you think about how we build our series. We're always doing x minus the center, x minus the center, x minus the center. So in this case, my interval of convergence is just the center, which in this case would be negative 1.